Hey, hi everyone. Welcome to this new series of system design. So today we are going to look into an interesting system design topic, that is search autocomplete system design. So what is this search autocomplete? So most of you, or rather every one of us, is nowadays familiar with Google search or searching on an e-commerce website, let's say Amazon, to search for various products. And as you type in this search box, we get one or more matches for search term which are presented to us. Like you can see also on the screen, like if I type SIN and F, then I get some multiple suggestions on the Google search bar. So these are like auto completed search options which are being suggested to us. So instead of typing the entire search thing, if anything matches with our search option, we click on that and we get the multiple links related to that search. So today we are going to look into and how we design a search autocomplete system design. So without wasting any time, let's dive deep into the details of designing our search autocomplete system design. So before designing, we need to clarify certain questions with the interviewer in order to get the requirements which the interviewer is seeking for in designing our search autocomplete system. So we will list down the requirements which are being needed to fulfill our requirements for designing this search autocomplete. Okay, so let's say, the first question we can ask is like, whenever we type it, is it the search option or the autocomplete suggestion which is being displayed to us, is it only from the beginning or is it also from the middle? So let's say we, for the time being, support only from the beginning. And the second question is like, how many autocomplete suggestions should the system provide us? Like, is it 5, 10, or what number of suggestions upon typing should the autocomplete search option should provide us? So let's say number of autocomplete suggestions is, let's say we have 5. And how is these 5 suggestions determined? Like which suggestions should be displayed to us? Which 5 suggestions should be displayed to us whenever we type something on the search menu? So this is basically dependent on, like we can say, frequency, historical query frequency, like number of times this particular words has been searched or any word with that prefix has been searched, we store the frequency of how many times this has been searched overall, and in order to that we display that suggestion in the search menu. And also by popularity, so these are related terms, like since it's popular, it has been typed a large number of times, so its frequency would be high, basically depending on the popularity. Now, do we support spell check? Let's say for the time being we ignore this thing, so spell check not supported for the time being. Fourth is like, is it only lowercase letters or also special characters are allowed, or uppercase? So let's say we only deal with, in this scenario, only lowercase letters. Fifth question which we could ask is like, how many daily active users do we have? So let's say daily active users which we have is, let's say, 10 million. And is it only the language which is supported for auto suggestion is, let's say, English is only the language which is being supported for the time being. So upon gathering these requirements which we need to design this search autocomplete, so we have we should be looking, primarily we should be focusing into is like fast response time. So like whenever a user types a character or types a particular word, immediately we give the suggestions to the user, like if he is searching something related to that or not. So the response times should be fast. It should also be relevant, like you are searching something and the suggestion is something else, and that should not be the case. So it should also be relevant, and it should be sorted in the sense, like on the basis of frequency. So suppose I type TW, so suppose I type TW, with this we can have Twitter, we can have something like Twilio. So Twitter is more popular than Twilio, let's say, so Twitter should be in the first after that then payload should appear, and like that. It should also be scalable, right? So everything should be scalable and highly available. This is also a primary aim which we should fulfill while designing our system design, any kind of system design, so that it can handle high volume of traffic, and also it ignores the slows down or unexpected experience, or highly available in the senses like the system is available even though some servers are down or some network issues happens, but the system is available to the particular user. So this is our primary goal, and with these requirements, with these things, we should be designing our search autocomplete. So let's now look into do some back of the envelope calculations of how much storage which we would be requiring. Back of the envelope calculations of the storage, let's say. So we assume that number of daily active users is like 10 million, and let's say number of average searches per day per person, let's say a particular person, let's do 10 searches in a day, and each search, let's say each search is of 5 characters, or I would say like each search, and on average consists of 4 words with 5 characters each. So the how this thing actually works, autocomplete suggestion, is like, suppose I type T. So depending on T, I will be having like tree or Twitter or something related to any word beginning with T. In the second case, whenever I write TW, let's say I write TW, then tree gets vanished. I will have Twitter, I will have Twillo, something like that. Or else if I write instead of W, I write TR, then I will have tree, or I'll have tram, and something related to TRs, any word beginning with TR. So for every character which we type, we have an autocomplete suggestion for that particular prefix. So for every character there is a request being sent to the backend to give us this autocomplete suggestion. So the data which we have is like data for each string is let's say one character, each character is of 1 byte, 4 words, 5 byte each, to 20 bytes of data. And this is the thing. So for every character entered into the search box which I just showed like TW or TR, a client sends a request to the backend for autocomplete suggestions, etc. So number of queries that is being done by a person is like 20 requests are being sent to the backend to fulfill the autocomplete suggestions, etc. So let's say suppose I type the word tree. So first I type T, one suggestion, one query is being sent. I write TR 2 queries, TRE, I write 3 queries, and then TRW. So total 4 queries are being sent to the backend. So let's calculate the queries per second. Is like we have 10 million daily active users, 10 into 10 to the power 6. Number of queries per day, 10. For each query, how many characters or how many requests are being sent, that is 20. So if I do queries per second, this is calculated for per day, so per hour is this, and for per second is this. So this basically turns out to be approximately 24,000 queries per second. So peak query per second, so let's say this is approximately 48,000, and let's say 20% of the daily queries which we have, so let's say 20% of daily queries which we have are new. So the storage which we require each day to store the newly searched queries is like, we have 10 million daily active users, 10 queries per day, and 20 bytes, since 20 characters, 4 words, 5 characters each, and among them we have 20% we are using as a new queries which is being searched, and this total the size becomes 0.4 GB. So that is 0.4 GB of new data is added to storage daily. So this is roughly some of our back of the envelope calculation, or some rough estimation of how much daily storage which we require to store the new queries. And this is an interesting thing, like each individual word does not contribute to a query being sent to the backend, rather each individual character of that word contribute to the query which is being sent to the backend to complete the autocomplete suggestions. Okay, so this is the overall highlight of how we calculate the storage which we require for designing our autocomplete suggestion, and these are the requirements which we have, we need to fulfill to design our autocomplete suggestion. So basically this is autocomplete suggestion mostly works on two main autocomplete suggestion mostly works on two main things. One is the data gathering service. So if we don't have the data, we won't be able to suggest any auto-completed suggestions to the particular query which is being searched by the user. So data gathering service, and another is the query service. Query service is like whenever a user types something with particular character being typed, considering the prefix, we suggest some particular queries. In our case, we will be suggesting top 5 popular or highly frequent queries related to that prefix. So this is the two things, so data gathering service and query service. So if we look into high level details of what is this data gathering service, how it works. So as the name suggests, so this is used to, suppose I have, this is basically we have a frequency table. So this is, let's say, a frequency table. What does it store? This stores a particular word and the frequency, the number of times it has been searched. So like, let's say I have words like Twitch, Twitter, then again Twitter, then I have Twilio. These are searched sequentially one by one. So whenever we enter this, so firstly my table would look like this. Initially it's empty, then again whenever Twitch is searched, it will be entered, we have an entry of this is 1. Again whenever Twitter is searched, we have another entry. So Twitch was already present, we have Twitter, so these are 1 1. Again whenever again we have this Twitter, so this value is updated to 2. I'll draw with a different color. Yes, this value is updated to 2. And again now let's say we have this Twilio. Since this is not present in the frequency table, this we will have another entry, and this value is updated to 1. So in this way we gather the data and store it in the frequency table. Next is like, so this is overall of how data gathering happens. So we sequentially are entering or searching some query like say Twitch or Twitter and like that, and then the data is being fetched and stored into the frequency table. Second, we have what we have is the query service. So query service is basically, query is basically the string which we enter in the search menu option, and with that string we basically suggest the auto completed suggestions on the search menu option. Okay, so this basically has two fields, one is the query and another is the frequency. So it uses basically these two things from the query frequency table which we just which we have just drawn here, which we have entered data into here. So it uses this query and uses the frequency table to get the suggestions. So like how does it work? Like let's say I have a table of various words along with that frequency. Let's say I have a frequency table. So let's say I have this frequency table where we have various words and the frequencies which are present against that individual word. So whenever suppose a user types, let's say TW in the search box, the following top 5, so from TW, as you can see, we have the highest frequency is the words which should be shown in the auto search option is like Twitter, Twitch, Twilight, Twin Peak, Twitch Prime, Twitter Search, Twilio, and all this. So all these things should be shown in the auto search option, auto complete option basically. And since we are displaying only the top 5, so among them these are sorted in the large to small order, like in non-increasing order. So first we will have Twitter, then Twitch, then Twilight, then Twin Peak, and Twitch Prime. So all these 5 will be shown in the autocomplete suggestion option whenever we type TW. So for TW, these are the options, autocomplete suggestions, which will be shown in the search menu once we type TW. So in this way, so in order to gather this, we can use a SQL query like select star from table 1. Let's say that this name is table 1, where query is like some kind of prefix. So like this TW can be here, or this is a general SQL query statement which we can use, and order by frequency and descending, since we need the suggestions to be sorted in decreasing order from the most popular to the least popular, and we have limit of 5 since we want only the top 5 autocomplete suggestions to be displayed. So we can use this SQL query. But the thing is, like, using SQL query is accepted whenever the data set is small, like we have only how much, let's say 8 entries here in this table, or let's say some 100 entries, then that SQL query would perform better. But when the data set is large, accessing the table using the SQL query becomes a bottleneck. So we need some optimizations. So in the next video of this playlist, we will be diving deep into certain optimizations and how efficiently can we retrieve these data, and how these data are actually stored in order to retrieve them efficiently. We will be diving deep into the details of those implementations. So thank you for watching this video. I will see you in the next video.